And for this chapter, the big idea is that forces cause changes in motion. If you have a soccer ball in the middle of a field and it's not moving, I think all of us would agree that there's no forces on it. And if it started moving, we would think that there was something taking place, some kind of force, outside force acting on that particular object. Probably the first person to really spend a lot of time talking about this was Aristotle. And he divided motion into two things, what he called natural motion, things that the objects tended to do, or violent motion, which was kind of against their will, I guess, in other words. What natural motion was things like rocks would fall, things going to, falling to the earth would be considered natural, or if smoke would rise in the air, that would be natural. For the heavens, for the planets and sun and stuff, circular motion was considered to be natural, and everything else would have been considered to be violent. So violent motion was kind of the results of pushes or pulls. You could apply a violent motion by kicking the ball and those types of things. So according to Aristotle, boulders don't move without a cause. They're just going to sit there and not move. And for about 2,000 years, it was pretty much believed that objects, when they were moving against their nature. It was against their nature to actually move. Something had to act on them to get them to move. So the state of objects was one of rest, and where, unless you came and pushed or pulled on something, it's going to sit there. And up until this time, that's pretty much what they thought. They thought the earth was just too big to be moved, so the earth was at rest, and that was why they believed that the earth was kind of the center of everything. Now, Copernicus came along, and as he looked at some of the things, he believed that the earth actually traveled around the sun. So Copernicus, living in late 1400s, early 1500s, came up with a theory that the earth was actually moving around the sun, which was very controversial at the time. And in fact, he did most of this in secret and didn't actually publish his works until the day he died. Or, he got near the end of his life, he published them, and then the first printing of it reached him on the day that he died. So that was the first that it was really put out there. So he proposed that the earth actually moved around the sun. Now, Galileo argued that the objects moved and would continue to move unless a force like friction slowed them down and acted on them. And he was a big supporter of Copernicus, and all of these ideas kind of got Galileo into a little bit of trouble with the church when he was supporting the idea of the earth going around the sun and so on. But Galileo is one of the bigger contributors to physics, and one of the important early scientists in here. But he believed that friction was a force that slowed down objects. So when objects rubbed against each other, and friction is caused by irregularities in objects, and even in very smooth objects, if you look at them microscopically, you would see these irregularities, and they tend to slow each other object down. If you could polish those down, you'd get rid of a lot of that friction. But, as long as we have friction, then those objects are going to slow down as they go through. So Galileo tested this idea by rolling balls up and down inclined planes and on flat surfaces. And what he found out is if you roll the ball downhill, it tends to increase in speed. If you roll it uphill, it tends to decrease in speed. And if there was no slope, then it would stay the same, pretty much. It would eventually slow down due to friction, but it would mostly stay the same. And his conclusion was that if there weren't any friction, this object would continue to go forever. It requires some type of push or pull to keep, to get it going, but then once it's going, it would keep going forever without friction. So Galileo's did other tests too. The other thing that he did was to roll balls down the hill, and noticed that as they rolled down the hill, they would also almost always roll up to the same height on the other side. And he would try this with different slopes, and what he would find out is that no matter what the slope was, the ball would almost always come to the same final height. It would always go the same height. So he tried this with different things. So what he did was say, well, look, if it goes here and it goes to that height, and I make it a little bit less slope and it goes here and it goes to that height, well, what's it going to do if I have a flat plane? Well, that thing should keep on going forever. It should never stop. That was his conclusion from that, which, if you think about it, is a pretty good conclusion considering that everybody else had different beliefs at the time. So if it keeps on going, so he claimed that Aristotle's idea was false, that the nature of the ball isn't to stop, but the nature of the ball, or the ball had a force or inertia, it had a property called inertia, which would continue to keep it going forever. All right, so think about this. If a ball is rolled across a countertop and rolls slowly to a stop, how would Aristotle interpret this? How would Galileo? And how would you? Well, according to Aristotle, he would say, well, it's seeking its natural state of rest. Galileo would probably say that the friction between the ball and the table eventually caused it to stop. And as far as what you would say, only you can answer that. Hopefully closer to what Galileo thought than Aristotle.